Hi, my name is Hakon Strande. I'm here today with my colleague Guy Merin, and we're excited to talk to you about how you can enhance your Android apps for dual-screen devices. In this session, we'll share guidelines and code samples. The Surface Duo provides the one-screen mobile device experience we all are familiar with. In what we call flip mode, where one of the screens is folded back, these devices behave just like any other mobile productivity device. But when the Surface Duo and other dual-screens devices are folded out, they become more than just a larger screen like we see in tablets and foldables. A dual-screen device has two distinctly separate screens, similar in concept to desktop multi-monitor setups. This hardware capability offers applications new opportunities for their users to interact deeper and easier with app content and controls. Today, we would like to share some ideas and code samples on how to capture the value of dual-screen devices, ideas that in principle also apply to foldables and other large-screen mobile devices. With dual screens, as I mentioned, it's more than just more screen space. As an app developer, you can take advantage of the combination of app patterns and device postures to deliver the right tools and context based on the task a user is trying to accomplish. Each of the two screens can have a focused or specific intended role in a broader productivity experience. For example, seeing a photo on one screen and a set of tools for editing that photo on another, so that you always have a palette of options in view, and you can see how tool changes apply to your photos in real time. Very powerful experience. The app has the opportunity to show more detail when the user spans it across the two screens. You can take advantage of a combined canvas to show a richly detailed map, for example, or naturally show 2 pages of a content article when the device is using a book posture. Dual-screen devices present new ways to achieve broader and bigger tasks. With two apps open and visible, apps can share and connect across without causing people to lose their context. Drag and drop content from one app to the next across screens, for instance. Or seamlessly pin one application to play video while you take notes on the other. We suggest there are 3 tiers of effort. Yes, there is a 4th option, do nothing. But we hope that what you see and hear here today will help motivate you away from that one. Okay, back to the minimal effort tier. Just load and run your app. It will open on the screen you launched it from. The Surface Duo uses a regular Android OS with some tweaks, so we aim for no app compat issues while running in single screen. So the tier 1 of getting ready for the dual screen device is to use the emulator to change the device postures. Does your app complete the UI flow in portrait and landscape in single screen mode? For tier 2, the readiness aspect is not something just dual screen device vendors like us would like to see. Google is also interested in applications supporting features that can improve user experience on larger screen device, foldable and dual screen devices. Consider drag and drop support, for instance, a feature that could add value to an app on all those form factors. For readiness tier 3, what does it mean to embrace dual screens, beyond what you would do for larger screen devices like tablets and the foldables? That is what we hope to get you interested in today. The dual screen mobile device can be used in many different postures. Using the emulator, you can test if your app follows the guidelines from Google when it comes to dealing with a resizable screen, a screen that can change dynamically in size, like when the device is rotated, and with the foldables already in the market. The same resize principles apply here when the user spans your applications on a dual-screen device. As you can see from the illustration, the Surface Duo can be rotated and the screens can be flipped, creating at least 6 very different ways your app could leverage to lay out its content and interaction controls in smart ways that take advantage of each device posture. If you already plan or follow Google's existing guidance for layout and orientation logic, the same UI will function well on the Surface Duo in single-screen mode. Supporting resizing and orientation changes should be your min bar if you want dual-screen device owners, along with foldables and large-screen device owners, to use your application. So what's the next tier? It is what Google has already asked the community to do for the last couple of years. Add features that make sense for larger screen mobile devices or tablets. These changes make our app better on dual-screen devices too. Let's take a look. Here are the main things to consider. As mentioned, make your app work well in both landscape and portrait orientations. Now, drag and drop is the big differentiator when the user have enough screen real estate to run 2 apps side by side effectively, which is the case with the Duo, but perhaps not with some of the existing foldables, something that will undoubtedly change in time for that category. Then your work here will pay off for foldables as well. Users may want to run 2 instances of your app, one on each screen. In the case when the device users folds the screen back, like this, Consider supporting picture-in-picture view for your app so your user can see your app and interact with it with the other application in the background. Widgets are going to be more important since users will run one app on one of the screens more often, and then the system main screen will be in the view a lot. Use it to give your users application information and notifications. Now, inking is also an interaction method that is gaining ground, and on the dual screen device, it can become a very powerful tool given the form factor. For instance, in dual landscape mode, imagine writing notes on one screen while watching a video report or other media on the other screen. Finally, when you're ready to take full advantage of the dual screen form factor, there are many exciting opportunities, and many of these make sense on foldables as well, especially in the future when those devices increase in screen size. Let's take a look. So what happens when your user spans your app? At risk of sounding like a broken record, a dual screen device is not just a larger screen, although for some content it's fine that way. It's really when the app makes use of two screens as separate entities for separate content that the power of the form factor shows up. Let's talk enlightenment. When you span your app across the hinge, look at how your app interacts with the hinge. Does it get in the way? If so, we have an API that will help you move things out of the way. Let's talk about the different postures. The first one is extend. The extended canvas pattern is the simplest dual screen pattern concept, but it's powerful. It is essentially using both screens as one large canvas, like most apps do on foldables. You may consider this pattern if your app has a free-flowing canvas, where the user is freely able to scroll to avoid the seam in case some UI is obscured, such as a map, or if you need a bigger canvas for such tasks as drawing. The master detail pattern has a master pane, usually with a list view, and a details pane for content. When an item in the master list is selected, the details pane is updated. This pattern is frequently used for mail and address books. We have this posture we call two-page. Some apps naturally tend to use a book-like paging experience. You can use the natural boundary of the seam to show several items from a collection, like pages or pictures, which otherwise might have required the user to view one at a time. In dual view, having two screens provides a natural affordance to compare and contrast two versions of the same type of content side by side, like two images, lists, or documents. Editing tools that benefit from having before-after states, side by side for example, markdown, code, and preview, or content and context side by side, for example a map and a list of restaurants. For the companion pane mode, it leans itself to exposing otherwise hidden UI that would not be accessible in single-screen mode. For instance, show complementary context to augment users' tasks, usually with a primary-secondary relationship, by elevating to the surface or to the screen previously buried level 2 functionalities for quicker access. Examples on this could be creative tools like an image drawing map, which could be placing the image canvas on one screen and using the other to hold the tools that manipulate the content of that canvas. Now, these are just our ideas. What would you do when your app is spanned? The device has a hinge, and that angle can be read by applications. Now, what do you use the hinge angle for? Well, we have some ideas. Bring up a game controls when you're in concave mode, for instance. Show someone else across from you, the user, the same or different app content in a flat mode. Now, imagination is the only boundary when it comes to using the hinge angle sensor, and we haven't thought of all the ideas yet. Show your users the power of your app when it's spanned into master detail or dual view or other spanned awesomeness that you want to build. Let's talk about the principle for spanning. Implementing support for one of the spanning modes means the interaction model should take advantage of both screens over the course of the user's app session, but the span state should not be required to complete the tasks and use cases your app supports. Spanning and deciding which screens to open an app on is the user's choice, not the application. Nobody wants a scenario where apps are chasing each other for the screen real estate. Keep the user in control. And finally, after spanning event by the user, consider what the user is expecting. Make the first app view in span state useful to the user immediately without having to take additional steps to leverage the fact that your app is now using both screens. And with this, I'd like to introduce my colleague, Guy Merin, to take you through the software SDK details.
Thank you, Hakon, from our awesome PM team. My name is Guy, and I'm part of the Surface Duo SDK team from the dev side. The Surface Duo SDK that we've just released includes 4 main components: documentation, APIs, a Surface Duo emulator image, and code samples to ease your development. Let's see each one of those. Our documentation are all online, and you can see the links into them in this slide. Our dual-screen development docs provide design assets and will evolve over time to include additional content, such as how to test your app. Our dev blogs are periodic and can be an easy way to learn tips and tricks and read about our SDK refreshes. Lastly, we have stood a tech forum site, which is where we can have a two-way conversation with you, the developer. This is where you can ask a question, suggest an idea, or upvote your ideas. Let's start with APIs. The display mask APIs is straightforward. It gives you a rect with coordinates for the location of the mask. You can use this API to understand if your app and layouts intersect with the mask and reposition controls and assets based on that. You can also construct and position controls differently based on the display you are running on. We've also added a hinge angle as a sensor. You can use Android native APIs and listeners for reading the sensors, which is in full range between 0 to 360 degrees. Let us know your cool ideas for how to use the hinge angle. We've thought of a few game options and smart tools that can utilize it. Follow our blogs and documentation for code samples. Lastly, we've added device capability. We don't expect you to fork your app and maintain a separate APK for Surface Duo. In your code, you can query the display mask feature, and in case it exists on the running device, run your dual screen code. We want to meet developers where they are at, so we added support for an emulator on Mac, Linux, and Windows. The emulator is integrated into your IDE. You can use Android Studio, Visual Studio Code, or any of your favorite IDEs. The emulator comes pre-installed with everything you need to operate a Surface Duo device, including our SwiftKey keyboard, our Microsoft Launcher, and Edge as the browser. You can also sign into your Microsoft account and connect to the Graph or other Microsoft services. Let's see a demo of the emulator. This is the Surface Duo emulator. In the last few months, we've partnered with Google and we've built a Surface Duo image that runs in the Android emulator framework and integrates with Android Studio. This is based on Android 10 and is the same look and feel you are familiar with from other Android development today. The changes we did include adding the dual screen, a hinge, and we're even adding support for the hinge angle emulation. You can launch app on both screens, swipe left, right, up or down, and it just works as a physical device. Let's now take a closer look at how this comes to life with one of our first-party properties, Edge. So this is the emulator here. I have Edge here pinned to the home screen. When I launch it, it launches on our documentation, dual screen documentation. Go check them out, and I can go and browse and read them here. Notice that Edge launches on the screen that I clicked it on, so I clicked on the right screen, it launches it here. Very easily, if I want, I can move it to the other screen, can run it with another app side by side, or I can even rotate the device to read it in another posture. Let's look at some of the code samples that we have built. The samples we built are hosted on GitHub and they're open for community contributions. They include a Gradle file both for x86 and ARM64 versions. The first sample we have is a Hello World sample. It has reference implementation for all the public APIs we have. The second one that you can see here on the slide is we have a set of all enlightened apps. So all these modes that we talked about before, master detail, two-page, dual screen, and extended canvas, you can see them in a single project and a single file. We've talked a lot about extended canvas, and I want to highlight a few dev considerations. Extended canvas is great to show more real estate and can work great on infinite scroll, such as a map. One thing to note in your code and layout is to make sure that the toolbars and controls are mask-aware and not hidden behind the mask. A consideration for master detail is to provide a default selected item. Otherwise, the right screen will show up empty. In the companion pane, you probably have controls and tools. You can change control layout depending on the device orientation. You can have a different view for your controls when the pane is on the right, or when you rotate the device and the controls and the companion pane is at the bottom. People have already been using two screens with their PC and laptops to achieve productivity on a daily basis. With Surface Duo, we are now bringing that productivity of two screens into your pocket and on the go. When a user launches your app, the framework will launch it on a single screen and your app will just work. This also allows the user to be in full control. This design choice we made keeps user in their flow while continuing what they were doing on the other screen. But even when your app runs on a single screen, you can still utilize the fact that it's running on a dual screen device. Let me show you an example using drag and drop. Drag and drop has been around in Windows for some time now and was added to Android native library with Android split screen view. But now, with dual screen devices coming to life, it makes lots of sense to add drag and drop support to your app. Let me show you a demo. This app is built natively in Java, and you can find it in our sample GitHub repo and our dual screen online documentation. In this sample, you can drag content such as text or images into another area within your app layout. But the magic really happens when you drag and drop content between two apps and across the seam. We made it possible at the platform level to drag content across the seam, and now with Android native support, you can utilize it between two apps. Let's see a demo with two apps. On the right screen, you can see our Edge browser, and on the left, it's the same sample app you saw before. Now let's try the same demo across both apps. Let's start with dragging text from a web page in Edge to the sample app on the left. Notice that you can get a preview of what is being dragged, and the sample app highlights the drop zone for easy discoverability. Now let's try that with an image. See how the preview changes, and now you can highlight a different drop zone based on the different content type. Now let's see how we do that in code. I want to highlight three main steps to support drag and drop in your app. The sample app we created contains fragments, one for the drag and drop source and one for the drag and drop destination. Start by calling start drag method, for example, on a long press operation. This will kick in a flow of system events which the system will call back into your app and notify you that a drag has started or ended. This is also the place to provide a preview for the drag operation using a Drago shadow builder. Lastly, in the destination fragment, add code in response to the action drop event. That will read the content which is being dragged, and then you can use it in your app. Let's move on to the next demo. Many Android apps use intents to launch activities in their flows. Let me show you a small trick that with just a few lines of code, you can utilize both screens and add value to your existing apps starting today. Let's consider a messaging app that has group chats. In this sample, you can see a group chat that I have with my family. When I want to write a reply to the group chat, typically the app is architected in a way that will launch a new reply activity. Starting that activity will talk over portions of the screen or maybe even the whole screen. That results in me losing focus and the flow and the context between the replies in the group chats. I will often bounce back and forth between the threaded view and the reply. However, by a few easy steps, I can launch the reply intent in the adjacent screen and keep the user in the flow. Let's see how we do that in code. When I add these two flags to the intent parameters and start the activity, it will now utilize the other adjacent screen. The cool thing here is that it will only do it if the adjacent screen is free. If you have another app running on that screen, it will launch the activity on the same screen that app is running now. It is that easy. It's 2 lines of code. This is the code base for the master detail sample. We have a helper that manages the dual screen mode. When we rotate the device to 270, we go back into a single screen mode, resulting in the app showing the detail view of the master detail item. Let's move to the next code sample, the dual view. What I want to highlight in this code is the usage of the device capability. Here you can see that we added a helper function to let the app know in runtime that is running on a Surface Duo device. Depending on the value, you can then construct the layout accordingly, for Duo device or for a non-Duo device. This is the code sample for the dual view. In my main activity, I want to set up the layout, but I want to set up the layout differently if it's running on a Duo device or on a non-Duo device. And for that, I have a helper function to let me know if I'm in dual screen device mode. Let's see that helper function. The helper function is super simple. It has a feature. It queries a feature of the display mask. And if the package manager has that feature, we return true. If we don't, it means we are not running on a Duo device and it returned false. Let's do a recap of what we've seen today. Start by continuing using Android Studio or any other of your favorite IDE. Then test your app on a single screen. it should just work. Continue using Google native libraries. Add multitasking features such as drag and drop, picture-in-picture, and others. Start thinking about inking. Can your app support a pen and an inking experience? Then start thinking about how you can enlighten your app with our dual screen patterns and the new APIs that you just seen. Thank you. We want to keep on talking to you, so use the link that you see on the screen or one of our tech forums. Give us your feedback and let us know what you think. Thank you very much.